Google things. You wouldn't be able to play Pokemon on your phone, right? I can't just tell my computer what to do. You see, computers don't understand English or any other human language for that matter. So what language do computers speak? Well, they speak in ones and zeros. All electronics speak that language of on or off, 0 or 1. But writing ones and zeros would be gibberish for us. It's hard for us to communicate like that, right? So humans have developed programming languages that are in between human language and machine language. That is, zeros and 1. Some programming languages are lower level than others. That is, they're closer to machine language. And other programming languages are higher level than others. That is, they're closer to English or a human language. And there are lots of programming languages. You have languages like assembly that is really, really close to machine code. You have languages like Python and JavaScript that are really, really close to English. Okay, that's great. We have these pieces, but what are we missing here? I mean, if I want to find flights to Hawaii, how do we go from here to, well, having, let's say, a website show us a display of all our flights, telling the computer to show those flight information on our screen? What are we missing here? Well, we have these programming languages that we usually write on a file, such as Python, JavaScript, maybe even Java. And then we somehow need to get these files that we write into ones and zero so that our machines can understand. Well, we need a translator, right? We take our code that we write, what we call a source code, written in a programming languages, and we give that to a translator that can understand that language, but also understands machine language. And this translator just translates these files for us. So what is this translator? It's not really a person, right? I'm not giving my code to somebody and somebody's going to just start shouting at the computer. That would be quite silly. What is this translator? Ready to have your mind blown? Well, it's another program written by a human. It can either be an interpreter or a compiler. Now, Python usually uses an interpreter, usually. And an interpreter, just like a translator, goes line by line through our code and executes our code on our machine. Compilers are a little bit different. They take your code all at once, reads the entire file all at once, and then translates that to machine code. So again, interpreter goes line by line, and each line executes an instruction. A compiler takes the entire file and turns it into machine code. Now, the differences between these two are a little complicated and beyond the scope of the course. And don't worry, we're going to come back to this topic. But I want you to just have this general picture that when we write code, whether it's Python, JavaScript, Java, C or C++, what we're doing is we're typing it in a language that is human readable. We're giving it to one of these translators, like an interpreter or a compiler, and these spit out code that are able to run on our machines. So to review, interpreters translate line by line and execute the line before going to the next line. Compilers translate all lines of a program to a file, usually called a binary, and execute the whole file at once. Now, in the next video, we're going to talk about this process a little bit more in detail, especially on how it works with Python. But why did I start with this? I mean, this is a complex topic. Most developers, especially if they're starting out, don't even know of this process. They just know that they write code and then it runs. So why did I teach this here? Because in order for us to be able to write Python code, well, I can't just write it anywhere, right? If you went right now to your computer, and let's say you opened up a text file like this one, and you started typing Python code, but for now we don't know Python. So let's just say I want to go search for Pokemon. Well, this might be code. We don't know if it is, but I can't just use this, right? I mean, this isn't really Python code, but how would my computer know what I'm talking about? In order for us to start writing Python, we need to download this translation service. And in the next video, I'm going to show you how to do that. I'll see you in that one. Bye-bye. Welcome back. We just learned what a programming language is. It's just a set of instructions that we give to a translator. And this translator can be an interpreter or a compiler. And we give these files that we create, our own code, our source code, to these translators. And they allow us to give instructions to machines, to computers, to phones. So we learned that we need these machines in order for us to write Python, right? How can we get these? Well, we download them. And here we download Python from the Python Software Foundation, from python.org. Now, before we download Python, we're going to wait a little bit. Because in this course, I want you to understand why we're doing things. Not just follow my tutorials, follow my videos, and, well, not understand the meaning and the fundamentals behind why we're doing things. You should be able to teach what you're going to learn. So let's take a pause here for a second. If this is the first time that you're learning a programming language, I have some good news for you. At the end of the day, all programming languages do the same thing. They tell the machine what to do. However, different languages have different ways of doing it. The beauty is that most languages have very similar principles. If this is your first programming language, well, this is going to be the hardest part, learning the first one. Afterwards, every new language you learn becomes easier and easier, in the sense that it's not the same as, let's say, learning English and Japanese, two very distinct languages. In programming, things become a lot easier as you learn that first foundational language. Now, if this is not your first language, and let's say you've written code in C, C++, or JavaScript, and you just want to learn Python, well, you're going to find these first couple of videos quite easy. But bear with me. Trust me, we're going to get into some advanced topics here. And we're going to make you a full-fledged developer by the end of this. But let's go back to this topic at hand, this idea of downloading this translator. The thing is, when people refer to Python, the language, they're most likely talking about the implementation. That is, they're talking not about the language itself, because Python, the language, is just a specification. You can think of it as a document that somebody wrote that says, hey, when I write the words DEF, that means something in Python. And when I write something like print, that means something in Python. But the translation machines, well, we can have tons of them. Different interpreters, different compilers. For example, python.org, when you click download here, you're actually downloading this, the C Python, because it's written in the C programming language. This is what you're downloading. It's a program written in C to read your Python file and, well, run it on a machine. But there's other implementations. For example, there's the Jython project. And this is a translator that is written in the Java language. There's 1.Py, which is actually written in Python. So it's a interpreter, it's a translation machine written in Python. And then there's also things like IronPython, which is written for the .NET framework. So here's a little trick question. When you download from Python, the official language is actually CPython. You're downloading this interpreter that follows the Python specification. But at the end of the day, it's a machine built by somebody. But these machines can, well, come in many forms. So when most people talk about Python, they're talking about this one, CPython, that, well, does our translation for us. It interprets our Python code and runs it on a machine. So we're downloading this. And if you want to really get into details as to what we're downloading, well, we're downloading a machine that takes our Python code, which, don't worry, we're going to write, and it goes through the interpreter, which we download using CPython. And this CPython is going to create something called a bytecode. For example, this bytecode prints hello world on our screen. Now, this might look like gibberish to you. And even for me, I don't know bytecode. This looks pretty, well, confusing, just for printing hello world to the screen. Well, the interpreter does that automatically for us. We don't see it. It's behind the scene. Now, once it creates a bytecode that is closer to machine code, it then uses the CPython virtual machine. Again, just something that runs this code, and then this code gets run on our machine. Now, you're never ever going to be asked this question in an interview. I mean, maybe. And most developers don't know this. But I want you to use this as a reference. That when we write Python code throughout the rest of this course, this is what's happening. We're writing Python. It gets interpreted line by line and formed into what we call bytecode. And this bytecode gets run on the CPython virtual machine, which runs on our computers, our phones, our laptops. And when we're downloading from python.org, we're downloading these two pieces so that once we have them downloaded, we can run Python. All right, that was a tough one. And I mean, we just got started. I hope your brain isn't exploding. Again, this is something for you to use as a reference. But you know what? I think it's time for us to learn how to actually run Python code. And don't worry, we are getting there. We are going to write our first Python program very soon. I'll see you in the next one. Bye-bye. All right. Oh man, we've been talking for a long time. How can we finally run Python code? I want to start coding, right? Let's download this translation service, right? Well, I'm sorry. Actually, this is something we're going to do later on in the course. And I know what you're thinking. WTF, Andre? Well, what is this? Kindergarten? I mean, come on. I came here to learn Python. Start teaching me Python. And I know. And don't worry. In this course, we're going to get you to have a professional setup with Python so that when you go into the workforce, you are doing what you're supposed to be doing. We're going to learn how to have all of these set up. First, we're going to have our terminal or command line where we can run Python from right in what we call a REPL. And then we're also going to use code editors like Sublime Text and Visual Studio Code. We're also going to use IDEs or integrated developer environments like PyCharm and Spider. And we're also going to use Jupyter notebooks. And I'm going to show you how to set up all of these on your computer, what the pros and cons of using each are, and how some of them might be used for machine learning while others might be used for writing quick scripts. And I know this is a lot, but it's good to have these skills depending on what type of job you want. And if you're a professional Python developer, well, you should be using most of these. But there's a problem if I start introducing this in the course right away. You see, these tools, you have to install differently based on what computer you have. So if you're using a Mac, a Windows, a Linux, maybe you're using a mobile phone, Because we want to get started right away and write some code instead of worrying about installations and making sure that your computer is all set up, I want to make sure that all of us can get started right away, no matter what device you're on. Now, if you're really keen, head on over to the section where I show you how to install all these on all of your devices so that you have it set up. And you can come back to this section. But I warn you, it's easy to run into problems and get confused when installing these tools. So I recommend sticking with what I'm about to show you, and I promise we will get you this professional setup. No other course is going to teach you all these things. But before I dive into these, we need to learn, we need to be able to just have fun and write some code. So what is this trick that I keep mentioning where we don't have to install any of these and still run Python? It's called REPL. You see, instead of us having to download this, we can go to repl.it. And when you go here, you'll get a login screen. Now, I recommend creating an account on here because trust me, it's going to be very useful. It's one of my favorite tools. And it allows you to save Python files just online. For example, once you log in and create an account, you can just create a new REPL, choose the language that you want to use. In our case, we want to choose Python. We can name our REPL. So we can just call it hey, and we can just create our REPL and check it out. Right away, we have, without ever downloading this Python translation service, we can actually start writing Python right here in our browsers. And this is going to work for anybody that has an internet connection and a browser because this interpreter just runs automatically here. And the beauty with REPL is that, you can save these files, you can have different folders. So as we work through the course, you can actually have a folder for all your Python work and just have a really nice organized file structure that you can access anywhere you have internet connection. Now, if you don't want to sign up for repl.it, it's completely free. You can also use this open source glot.io, which again, you go to Python and you're able to run Python online. So take your time, sign up for repl.it, and let's get started with our first Python program. I'm finally getting there. In the next video, we're going to write our first piece of code. No more waiting. It's coding time. So I'll see you in the next video. Bye-bye. Hey, you're still sticking around. That's good. I didn't bore you with all my talking, but yes, in this video, finally, we're going to write some Python code. Holy moly, thank God, I thought that was going to last forever. All right. So what is our first program going to do? Well, let's create a very simple function. And probably the first thing any programmer learns to do, to print our own name. So in here, once you have your repl.it set up, or remember, you can also use glot.io, we're simply going to write print. And then you see over here that it gives us some information, but all we want to do is write brackets, a quote. So you can do double quotes here or a single quote, and just type your name. And if we click run, on the right side, we've just written our very first Python program. Very exciting. But what's happening here? Well, let's look at everything. First of all, if you're confused why my thing is dark and yours might be light, it's because if I go to settings, I've set my theme to light or to dark. I prefer the dark version. But you can change some of your settings. You can change the font size if you want. Based on when you watch the video, this website, the look might be different, but most of the settings should be the same. We see that we have a main.py, which is the Python extension. Any file that has a .py or py is a Python file. So what we've just written here on line 1 is a program that prints in this case, Andre Nagoye, or in your case, your own name, and we've written it to this file. Now, REPL.it takes this file, already has this interpreter for us. It runs this piece of code, gives this source code of main.py to the interpreter, and runs it right here on our right side. If you look over here, we're using Python version 3.6.1. And down below, we see that, we have Andre Nagoye printed. That's awesome. So this is our code running. Remember this diagram. All we've done is we have our main.py, where we wrote print Andre Nagoye. We gave it to the interpreter that the REPL already provides for us. That interpreter takes our code, converts it into bytecode, and here it'll say Andre Nagoye, and then it runs it in the CPython VM, which was on the right side that we saw. And it finally prints our name because it tells the machine, hey, we want that text printed. So that's what we're seeing here. This is the CPython virtual machine essentially running this code and telling this machine, hey, I want you to print this. All right, but this isn't very exciting. I mean, let's make this program a little bit more dynamic. For our first program, we want to do something more impressive than just print name. So I'm going to teach you another thing we can do in Python, and it's called input. Now in here, I can say input, and you see that REPL actually gives me some information saying that, oh, I have this. You can just click here. And this input over here, well, what can we do? This input is going to prompt a user, and if I hover over it, you can see how it's giving me some information. But input simply gives us a way to capture information. So let's say, what is your name? And if I run this code, we see that we have our Python code running, and it's asking me, what is my name with this cursor here? So I can actually type something here. I can say, Andre. And if I hit enter, well, there you go. I've just typed in my own name. Nothing that exciting, right? But this is where code becomes interesting because we can store this information on our computer. So again, these are things that we're going to go over in detail in our basics Python section. But just to write our first code, let's assign this to memory. That is, let's say that name equals whatever is the input of what is your name. And then finally, we can just print the name. So remember, the interpreter is going to take this first line. It's going to ask, what is your name? I'm going to type something. That typed information is going to get assigned to name. And then finally, we print name. Remember, an interpreter takes line by line, converts code to bytecode, and then finally runs it. So let's give this a try. I'm going to click run. All right, what's your name? My name is Andre. Did you see that? I typed in my name, hit enter, and then it printed out Andre. So for the final feat, let's greet. So we're going to say print hello, and then plus name. Now, don't worry about the syntax. We're going to go over it. But all we're doing is saying hello and then adding our name to the end of this. So let's see what happens. If I run this and say, what is your name? My name is Andre. And I hit enter. I get hello, Andre, but no spaces. So let's add a little space. Hit run again. For the fourth time, my name's Andre. And it says, hello, Andre. There it is, our first Python program. Now, it's not very exciting because it is our first program. We're just learning the steps here. But I hope because we've covered some of these topics ahead of time, that this isn't just pure magic, right? You understand that this is source code. This is main.py that we give to an interpreter that runs our code line by line and then executes our program. In this case, our what is your name program. How cool is that? This is just the beginning. We're going to get more and more advanced here. See if you can play around with this. We don't know that much about Python yet, but I hope this gets you excited because, well, there's a lot more coding coming along. I'll see you in the next one. Bye-bye. Hey there, this is Andre from the future. Exactly right after I recorded the videos in the REPL, well, REPL.it decided to upgrade their Python interpreter to the version right here. Now, you might be asking yourself, hold on, if I go to python.org, the version of Python is higher than this. As you can see, the latest version of Python is right here. But again, REPL just takes a bit of time, so we are fine as long as the version is 3 or higher. Now, I want you to keep in mind that REPL usually implements the Python interpreter a little bit later because they have to work out some kinks, make sure that it's integrated properly onto their website. So this number might be a little bit lower than what you see on python.org, but don't worry, everything that we do in this course, you're going to be able to follow. As long as we're using Python version 3, we're all set. Now, depending on when you watch this video, this number might be even higher, but again, everything we're going to learn, you're going to be able to follow. Just keep in mind what I said before. That is that these versions are constantly going to upgrade and constantly going to evolve. In this course, we're using the latest version of Python, but because REPL now has a higher version, it allows us to do some neat things that perhaps we weren't able to do in older versions of Python. For example, later on in the course, we're going to talk about something called the walrus operator. And this is a new feature that is new to Python 3.8. And because of that, we're going to be able to use it inside of this REPL. But we're getting ahead of ourselves. You'll see that when we talk about the walrus operator. Anyway, just a quick note. Let's get back into it. Welcome back. Whenever you start to learn Python, it's unavoidable that you'll encounter this topic of Python 2 versus Python 3. So what is this all about? And it's a very important topic. Now, first of all, Python is created by a human, right? As a matter of fact, it was created by this person right here. His name is Guido. Now, a programming language is always evolving. It's not like somebody creates a programming language, it's perfect, and that's it. No, all programming languages are constantly being updated. Just like on your phone, you constantly get software updates. Well, a programming language is constantly evolving to make it better and better because nobody gets it right the first time. And by the way, this is a great video that I'm going to link to. You can check it out in the resources. Now, Python was created in 1991 by this gentleman, and it was actually created with the name from 1.Python, which was a British comedy group. But like I said before, the language is always evolving. And in 2008, Guido decided that, well, Python version 2, which has been used for a very long time, had some things that he and the community wanted to change. So in 2008, they decided to create Python 3, a new version of the language. Here was the tricky part. You see, when you update software, let's say on your phone or even on your laptop, you expect things to keep working, right? Updates are usually good, they're improvements. But some of the features that Python 2 had, they didn't like, or they wanted to change completely. So Python 3 introduced what we call breaking changes. That is, if you updated to Python 3, remember the Python interpreter the C Python translator that we've been talking about? Well, as soon as you updated that, your Python 2 code wasn't really going to work. It's like updating your phone and then all of a sudden, all your apps stop working. That doesn't sound very good, does it? That's pretty much what happened in 2008. Most companies that wrote their code in Python version 2 just kept Python version 2 because, well, for them to upgrade meant that they had to go through their code line by line and make some changes. Now, these changes weren't that significant. For example, I'll link to some resources, but don't worry, these are topics that we're going to cover throughout the course. But different things wouldn't work. For example, the print function, which we've learned about, in Python 2, it didn't have the brackets. It looked like this. And Python 3 used the brackets. So all the code that had print like this would break. Now, the differences themselves aren't that big. I mean, you can read through them and we'll talk about this in the course, but overall, you can learn them in a day. That's why when we learn Python, most of the time we're learning Python 3, but you can use the same knowledge with the older version of Python. Now, you may see some Python version 2 code out there for companies that haven't upgraded, but it's now what we call legacy. That is, come 2020, it's going to stop receiving security updates. So the community, Python community as a whole, is saying, hey, everybody start using Python 3 because we're going to stop maintaining Python 2. So we're going to learn the most up-to-date version 3 in this course, but we're also going to touch on some older topics that Python 2 covers, just in case you encounter them when you work for a company that perhaps still supports legacy code. But as I mentioned, the whole community as a whole is moving towards Python 3. This website, for example, shows you how many big packages, popular Python packages, which we'll talk about, support Python 3. In our case, there's only 4 popular packages that don't support Python 3. So what I'm saying is Python 3 is the way to go. It's the way of the future. That's what we're going to learn in the course, but I want you to be aware of the historical context. And one thing to be careful of when in this course you're searching for answers, or maybe I have some exercises that require you to Google things. For example, if we go to the Python documentation, which is the reference of how, well, what the programming language does, you'll see that you can choose the versions here. And you always want to go with the latest, but you might find some answers online that still use Python version 2. So you want to make sure that when you're searching for answers, that you don't encounter any legacy code. Like I said, 95% of the time, it's mostly the same, but you usually want to keep current with the language. It has the most community support, most up-to-date, most secure language. So, just a quick note about Python 3 versus Python 2. When you hear the word Python, people are generally just talking about both Python 3 and Python 2. And if you remember, in our REPL, when we created our first program, you see that you're using Python version 3.6. This is the default standard version that REPL comes with. So right away, we know that we're using Python 3. Awesome. It's up to date. It's new. The whole community is behind it. Well, most of the community is behind it. So we're all good to go. I'll see you in the next video. Bye-bye. Welcome back. Let's do our first exercise. And this exercise is going to be really easy for you to skip, but I do recommend that you actually do it. I know it's not coding, but it's important because you'll learn that teaching somebody a topic actually helps you learn. So this is the exercise. Based on the videos that you've watched, how does Python work? But don't think about it in your head. I want you to talk to somebody. I want you to teach somebody how Python works. So the first thing you're going to do is go to our community, our Discord community. We have lots of people here. We have about 1,500 people online right now, plus some alumni, plus some star mentors. Well, there's a lot of people. What I want you to do is go to the Programming Buddies channel, if you haven't already, and find a buddy. And with that buddy, whether that person is taking a Python course or taking a JavaScript course, it doesn't matter. Just say, hey, can I spend maybe 5 minutes teaching you how Python works, and see if you can explain it to them, how it works just like you've learned. And then after you've done that, I want you to go find a friend or a family member that has never done programming before and see if you can explain in simple terms how Python works. That is, how Python gets written as source code. We use this translation service called an interpreter to run this code and then, well, spit out some instruction for our machines. I kind of gave away the answer, but you know what I mean. I want you to practice teaching somebody this, because by understanding these fundamentals, it's going to help you learn more and more and understand how things work underneath the hood as we get more and more advanced. All right. First little exercise, it shouldn't be too hard. I'll see you in the next video.